Well, good morning to one and all. My name is Jinaresh. Here, the subject is about the introduction to robotics. Here, the topic is about the design and characterization of a lightweight and fully portable remote actuation system for use with a hand exoskeleton. Let's move on to the topic. At first, the abstract of the topic. Here, the enabling individuals who are living with reduced mobility of the hand to utilize portable exoskeletons at home has the potential to deliver rehabilitation therapies with a greater intensity and relevance to activities of daily living. Here, various hand exoskeleton designs have been explored in the past. However, devices have remained non-portable and cumbersome for the intended users. That's how we know who actually these exoskeleton robots were being helpful for our the persons who are disabled. Here, we investigate a remote actuation system for wearable hand exoskeleton, which moves weight from weakened limb to the shoulders, reducing the burden on the user and improving portability. A pull board cable was used to transmit actuator forces from a backpack to the hand with strict attention paid to total system weight, size, and the needs of the target population. We present the design and integration of this system into a previously presented hand exoskeleton as well as its characterization. That's how the abstract been understand. Let's move on to the introduction. Here, before knowing the introduction of the topic, here we can see a figure which related to the actuation system right middle of the frame. Here, it was a figure of hand exoskeleton where the introduction topic is about the loss of mobility in the hand is a condition which is faced by many individuals manifested through various mechanisms such as orthopedic or neurological injury, general aging or chronic disease. The incidence of stroke related disability in particular, muscle weakness in the arm is present to varying degrees in the majority of stroke patients. Here, leading to difficulties in lifting the arm against the gravity, controlling movements, or grasping and manipulating objects. Much of the initial focus in robotic rehabilitation was on the training the proximal joints of the arm. However, the improvements in the proximal joints were not seen to generalize to the distal joints. The design and review and requirements. In general, a remote actuation system that which could reliably set a linear position at its output was designed. The design would have to minimize the drawbacks of remote actuation, namely transmission loss and the reduction of the positional accuracy for a remotely actuated system. Direct control of force at the output is challenging due to transmission losses, which will change depending on the orientation of the system. Implementation of force control through a series elastic element and a positional control of the output would be possible with the proposed architecture. That's how the design review and requirements have been done. Here in the next figure, we are discussing about the picturization of the exoskeletal diagram. Here we can see the two figures where the back side and the hand side were the two sides. M3 cables, M3 locking nut, and 5 odd board and cable housing, M3 cable terminal, Teflon coated 1.5 mm 5 wire rope. These were the few parts. And on the right side figure, we can see the line actuators, motor driver, sensor, board line, wireless radio, lithium ion battery, aluminum frames, M3 cable terminals, UHM WPE, guide block, board and cables locked as like this. By using these kind of parts, the exoskeletal part which is used for the sake of the human needs, these were being manufactured. Here the let's move on to the hand exoskeleton integration. Finally, the actuation unit was integrated into the hand exoskeleton of Ereta, etc. Two of the four available actuators are utilized, providing coupled movement of the index and middle fingers and the ring and the little fingers. Here, finger actuation on Arata's exoskeleton is accomplished with a three-layer sliding spring design depicted in figure number 4, which is shown in the next slide, whereas the layer closest to the fingers is fixed, while the center layer is actively being pushed and pulled. Here, the second slide is related to the picture of the hand exoskeleton integration. Here, here it was a figure which is about the hand exoskeleton integration, that it is explorer view of Arata's exoskeleton modified for remote actuation, which is the right side for the purpose of right hand, with details of Arata's finger mechanism, details of finger mechanism design, which can be found in the Arata, where here we can see few of the parts which we studied in our academics, that is actively sliding spring, passively sliding spring, fixed spring, joint center, which are being availably present in the work which would be worked for the functioning of the movement of the fingers as like that, where finger coupler were either side of the this arata finger mechanism, and the position sensor wiper is present between these finger coupler and joint center, whereas the 3D printed housing cap is the other which is present over the arata finger mechanism, and few other parts like 3 wide bushing, cable terminal, sensor board, pneumatic fitting, bearing, or few other. At last, finally, the conclusion about the topic is the loss of positional accuracy inherent with baud and cable transmissions was compensated for through closed-loop positional control of the transmission output. The achieved weight reduction makes hand exoskeletons more suitable to the intended user, which will permit the study of their effectiveness in providing long duration, high intensity, and targeted rehabilitation as well as the function assistance. Here, the enabling individuals who are living with reduced mobility of hand to utilize portable exoskeletons at home has the potential to deliver rehabilitation therapies with a greater intensity and relevance to activities of daily living, whereas hand exoskeleton. That's how these exoskeleton and the robotics were being impact upon the society, and it how it actually been worked to the mankind. That's how the technology increases and helpful for the mankind, which makes utilization of the portable exoskeleton at home as a potential to deliver rehabilitation therapies with a greater intensity and the relevance to the activities of daily living. Whereas of the exoskeleton, which of the different kinds. The reference of this topic is it was in IEEE International Conference on Robotics and Automation, Transaction on Mechatronics, the books related to the International Conference and Rehabilitation Robotics videos. That's how the process of manufacturing of the hand exoskeleton integration is being done, and design and review of the requirements of the hand uh, exoskeleton is being done. And whereas we understand and well known about the structure of the hand exoskeleton, which actually being individuals manifested through the various mechanisms for the orthopedic process of process. And that's how the which worked as the exoskeletons. Thank you all.